Hello, everybody. My name is Guilherme Rosa. I'm a faculty member at the Department of Animal Data Science here at UW-Madison. So I'm going to talk about big data for big decisions in pig production. So we've seen lately the accumulation of data in many different sources. So we have digital technology, sensor technology being used at farms or for weather and for many other sources of information. And we see the application of different ways to mine this data and learn from this available data. So I'm going to show you two examples that we developed in our lab. One that is related to this first topic of sensor technology, and the second that is on the analysis of data, farmer recorded data. So first, the sensor technology that we are using mostly is based on cameras and image analysis. So we see image computer vision, as we call, being used in many different areas like self-driven cars or monitoring people in cities and so forth. So there are many ways this kind of technology can be used in livestock production as well. For example, there are cameras that are called depth sensors or 3D cameras. So these cameras, they give the distance. So when you take a picture, so each pixel of the picture gives the distance from the camera to the object. So if you take a picture from a pig, you can look at the height of this pig, the volume of this pig, and so forth. So we are using this kind of cameras to estimate, for example, body weight and body composition, as I'm going to show you here. So it's very important for you to monitor growth of animals because you can better feed animals, you can detect animals that maybe are sick and not growing well, and so forth. But of course, bringing animals to the scale is labor intensive, is stressful to the animals. And so if you could develop a way that we non-invasively and non-stressfully have an estimate of body weight, would be very interesting. So this is the research of a former student, Arthur Fernandes. He works for Cobb Vantres, a poultry breeding company now, and we published this paper last year. So we had pigs from PIC, there is a pig breeding company, almost 700 pigs with body weight that we got from the electronic scale, and we had also information on muscle depth and back fat from ultrasound. Okay, so and then we brought animals to the scale and took pictures. So for example, here we have an automated, so the way we did this, so the animals come, so this is the 3D camera, and automatically we look at each frame of this video and we choose good pictures. Automatically we choose animals, pictures where the animal is in a good position, in straight position, not touching the wall and so forth, okay? So, and then we used this computer vision techniques. There is one that is called deep learning. So it is a basic, it's like when you make bread or cake. So you have input and then you do this data analytics and you get an output. In our case, the input is the image, and we train the model with the weights that we had from the scale. And then once you have the model trained, now you have pictures that come from new animals, and then we get an output that is the body weight that you are estimating, okay? And muscle depth and back fat as well. So we actually compare different models, different approaches, and the deep learning was the best one. For example, for body weight, we got a little over 3 kilos of plus or minus on an animal that is 120 kilos. So it's a very good very good estimation. These animals were not fasting when we weighed them. So there is variability also on the weight from the scale. And so we were we were glad with the results. Muscle depth and back fat is not as good in terms of R squared and mean absolute error, but it's reasonable. And of course, if we increase sample size, we can increase this performance as well. So a second example that I want to show to you is using farm recorded data and integrating the farm data with other sources of information to try to learn about how you can improve the system. So this was a collaboration with IOSelect Farms, and they had data using MetaFarms, the software. We had carcass information from JBS, and we use weather data also. So we integrate weather data from public available database. So we had almost 3 years of worth of data, many variables, performance, economics, management, and facilities. So Tiago Passafaro was my student that developed this research during his PhD. He works for Zoetis now. And so he did different projects, different chapters on his thesis. And I'm going to show you one of them that is with pig transportation. So these are the finishing farms from IOSelect Farms. So we had information on many shipments, like almost 2 years. And we had information, our interest here was to see what are the factors that increase the death or the likelihood of having this slower hogs at arrival in the slaughterhouse. So we published this paper 2 years ago, and Tiago Passafaro is the first author here. And we have Noah Williams from IOSelect Farms and Denise from PIC. So 1 year and a half actually of this data, 26,000 shipments from over 400 farms, 2 plants from JBS, 4.5 million hogs in this database, okay? So we had information on many things like the truck company, the site, how far they travel to the slaughterhouse, the driver, if the driver was the owner of the truck or an employee of a company, the average weight of the pigs, and so forth. And then we also brought weather data. So we have wind, we have precipitation, we have temperature and humidity. So we have this index now that is temperature and humidity index. So just for you to have an idea, the total loss, the average across this 4.5 million hogs, 0.76% died. So almost or around 35,000 hogs. So it is a big loss, and of course, a big concern from an animal welfare standpoint. Okay, so we run the model. So it's a statistical model combining all this information that we had available. I'm not going to go in detail on this, but we found some interesting results. For example, driver, when you have the owner of the truck driving the truck, you decrease significantly the likelihood of death or slower hogs at arrival. And then some other results that some were kind of surprising and some were quite expected. So this is the likelihood of getting death or slower hogs as a function of distance. So we're up to, let's say, 100 miles, so this is kilometers, so up to 100 miles, it seems that it's kind of increase a little bit the likelihood, or it's kind of almost stable, but then decreases actually up to 300, almost 400 kilometers, the likelihood decrease. So it was surprising for us. And we said, how come you travel longer and you decrease the likelihood of death? But then we look at the literature, and there are other people that found similar results, and they indicate that the loading and unloading of pigs, these are the two most stressful times. And then if you have them too close in time, these two stressful events is not good. So it's better to wait a little bit after loading to unload. And then, of course, this should go up if you have longer than 400 kilometers, okay? And then some other quite expected results. So this is temperature humidity index. Of course, so it's too hot, too humid, or too cold, the likelihood of death increases. And then, of course, as a function of average weight, so larger pigs, heavier pigs, they have higher risk and likelihood of dying or getting is lower, okay? And then this is a more complicated, but it's the likelihood of death as a function of an interaction between wind and precipitation. Okay, so I'm just going over quickly these results. It's an interesting paper. If you are interested, you can download or email me, and I'll be glad to talk to you. And if you have questions, also please feel free to get in touch. So just a quick conclusions. We think the computer vision, the cameras, and there are different technologies. I'm using the 3D here for body weight, but the color camera or the thermal camera, there are different applications, and we believe this is something that is going to help a lot pig production, because they are inexpensive, they are non-stressful, non-invasive to animals, so they can be very helpful. There are many other traits that you can imagine that we can monitor, for example, leg problems, locomotion score, behavior. We have another project where we are monitoring behavior, looking at the tail biting and so forth, mostly from a genetic selection standpoint. And then the second group of projects that we have, that is this integration of data from different sources and the data analytics to try to learn how we can improve production systems. For example, these results that I showed to you, this is just an investigation of the potential, the important factors affecting the likelihood of death. But now the next step is to develop an optimization algorithm so that you can find the best ways, like when you know when you are shipping pigs to the slaughterhouse, how big they are, what's the weather, which companies you have available, the truck companies. So you need to optimize the combination of truck driver, truck companies, weather, what time of the day you transport pigs, and so forth, so that you minimize the chance of the risk of death. Okay, that's what I want to talk to you, and I'll be glad to answer any question. Thank you very much.